Okay, so here's some warm-ups from what we did the other day. So the first one here, you're going to set the radicand x plus 1 greater than or equal to 0. Subtract 1, but x cannot be 7. So we need to get rid of that. So we're going to go from -1 to 7, skip 7, and then move on. And there should be a nice parentheses right there. So here the nice thing is I've got an odd index, an odd root. I can put anything I want in there for x. So my domain is all real numbers. Okay, let's talk about simplifying radicals. We've done it with numbers, now we're going to do it with variables. A way to think about this is the square root. So how many x squareds do I have in x to the 7th? And I look at it that way. So x squared times x squared times x squared times x would be x to the 7th. So then you can break them up. You can do it with multiplication, division. You cannot do that with addition and subtraction. But this is a property of radicals. Now, what is the square root of x squared? It's just x. What is the square root of x squared? It's just x. Square root of x squared, just x. So I have x times the square root of x. So I have x to the 3rd times the square root of x. The idea is we have an unwritten number right here, and you can just do that. 7 divided by 2 is 3 with 1 left over. That's basically all you're going to do every time. Okay, n is called the index, the nth root. If nothing written, the index is 2. X to the a is the radicand. Everything that's inside the radical is called the radicand. Divide a by n, that is the power on the outside. The remainder is the power on the inside. Okay, that's basically what you're going to do every time. So x to the 9th, and we've got a 2 here. So 9, this is good old like 3rd grade division, divided by 2 is going to be 4 with a remainder of 1. So I'm going to have x to the 4th power on the inside and x to the 1st power on the outside. Okay, I want you to practice the rest of these. Let's see what we can do. Okay, so same thing here. 8 divided by 3 is 2 with a remainder of 2. So we're going to have x squared on the outside and the cube root of x squared on the inside. And so this number should always be less than this number. So same thing here. What's the square root of 36? 6, so we have that. And then 14 divided by 2 is just flat out 7. So we get that. You might have to have checked this out. You can use your calculator to find the 5th root of 243. All right, and I think that's 3. And so then 20 divided by 5 is 4. 25 divided by 5 is 5. And we got nothing left inside. Don't get overly concerned here. There's a 2 here. 16 divided by 2 is 8. So I'm just left with x plus 7 to the 8th. Same kind of thing here. 25 divided by 3 is 8 with a remainder of 1. So I have 4x minus 7 to the 8th power. And then 3 Square roots of 4x minus 7. All right. We have to get into a thing here. Don't get too hung up on this, but the square root function is always asking for a non-negative. So if x squared is 9, then we know x is 3 or negative 3. But literally this symbol that says the square root of 9 is asking for the non-negative square root of 9. So that's only going to be 3. An odd power can result in a negative. For example, negative 1 to the third power is negative 1 times negative 1 times negative 1, which is negative 1. So an equation with an odd power can only have one solution. So x to the third is negative 8, then x has to be negative 2. So by definition, an even root function must produce a non-negative result. So if the result could be negative, we have to make sure it is positive. This sounds very confusing. We're going to use the absolute value, but there's a straightforward rule that we will use in just a second. So a different way to put it. Just this is trying to make an example here. The square root of x squared should be x. But plug in negative 1 for x, and I get, but what is negative 1 squared? So this would be the square root of positive 1, which is 1. But that doesn't work with this. If I plug in negative 1, I should get out negative 1. So what we say is the square root of x squared simplifies to the absolute value of whatever x is. Because it's got to produce a positive result. So in other words, if you did put in a negative, the output is going to be the positive version of that. So whenever you simplify radicals like this, we have a very specific rule. It's called the even-odd rule. If you have the even root of an even-powered variable, the result is an odd-powered variable, you must use the absolute value of that variable. A lot of words. Even root of an even power and result is odd power. Use the absolute value. Even, odd. So here, I've got even, and 6 divided by 2 is odd. So I'm going to get x to the third, but I went even, odd. So I have to use the absolute value of 3. Of x to the third. So same here. Now the number doesn't matter. That's just going to be 6. But 10 divided by 2 is 5. Even, odd. So it's the absolute value of x to the fifth. So now here though, I'm going to get that 6 again. 8 divided by 2 is 4, so it's even. So I don't need the absolute value. And the reason you don't need the absolute value is because x to the fourth is always going to be positive anyway. Whereas x to the fifth or x to the third could be negative. If x is negative, x to the third is negative. If x is negative, x to the fifth is negative. But if x is negative, x to the fourth is going to be positive, and we get the positive result that the square root function dictates. Okay. There you go. Good luck.